The question says, find the accumulated value of $100 at the end of 2 years. So we'll put K is equal to 100 and T is equal to 2. And for A, it says if the nominal annual rate of interest is 6% convertible quarterly, and by this we'll get M equals to 4 and I equals to 0.06. And you'll use the formula AT is equal to KAT, and the AT is using this formula 1 plus I over M in the power of MT. And you insert the values and you'll get $112.65. And for B, if the nominal annual rate of discount is 6% convertible once every 4 years, you lay out the information and you'll get D is equal to 0.6 and M equals to 1 over 4. And using the same formula, but replacing it with D and this being negative, you get $114.71. For question 29, the question says, given that IM is equals to 0.1844144 and D, the power of M, is equals to 0.1802608, find M. To find M, we'll lay out all the information first, and we'll do you will put the formula 1 plus IM over M is equals to 1 minus dm over m power of -1. This is the formula, can be seen in the book, and we just insert the values in it. And by doing all this and by doing the calculation, we'll get the m, and the m is equals to 8. For question 35, an investment is made for 1 year in a fund whose accumulation function is a second-degree polynomial. So we'll state that this function, second-degree polynomial, this function is stated in the book, the second-degree polynomial. This is the function, and you do the timeline, where the question says the nominal rate of interest earned during the first half of the year is 5% convertible semi-annually. The effective rate of interest earned for the entire year is 7%. Find delta 0.5. You draw the timeline first of A with the time 0, and this is the interest for the first half of the year is 0.05, and this interest of 0.07 is earned for the entire year. This, and if we put A and we insert 0, is equals to 1. And by inserting the 0 in the function above, and is equals to 1, we'll find C. And next is this A 1 over 2 equals to 1 plus I over M. This is from the nominal rate of interest earned during the first half of the year. We insert it into here, and then we'll get this. And for the time 1, we use the formula effective rate of interest, and then we'll get A plus B equals to 0.07. And by finding all of this, we can get A and B. A is 0.04 and B is equal to 0.03. And to find delta 0.05, we have to differentiate the AT above here and then over A, the accumulated value, and you'll get 2AT plus B over AT squared plus BT plus C. And you insert the values in here, the A and the B's and the T, and you'll get delta 0.5 is equals to 14 over 205. In question 40, I've laid out all the information. It says this delta T equals to 0.01T plus 0.1, and that is for 0 less than T and less than 20. It's between T is between 0 and 20. And then for fun Y, we draw the timeline where it says in fund Y, money accumulates in an annual effective interest rate I. An amount of 1 is invested in each fund for 20 years. The value of fund X at the end of 20 years is equal to the value of fund Y at the end of 20 years. Calculate the value of fund Y at the end of 1.5 years. And by that, we draw the timeline for fund Y because we invest 1 in each year. So we put 1 over here, and the interest rate is I. And it says to find the end of 20, so we put K here. And for fund X, it says the value of fund X at the end of 20 years is the same as fund Y. So we put equal here. The next step is we integrate the formula above, the equation above, and it gives T is from 0 to 20, so we put 20 0, and we find delta T is equal to 4. And to find the interest rate, to find the value of fund Y at the end of 1.5 years, we put exponential here in the formula. So we insert it in here, and then the reason it's 1.5 over 20 is because it says it wants the value of fund Y at the end of 1.5, so it's 1.5 over 20, so we get E 0.3. For 47, method A assumes simple interest over final fractional periods, while method B assumes simple discount over final fractional periods. The annual effective rate of interest is 20%. Find the ratio of the present value of a payment to be made in 1.5 years computed under method A to that computed under method B. So for method A, we use the formula simple interest, and for method B, we use the simple discount. And it stated that for method A, interest is equal to 0.2, and we don't know the discount. And it stated that T is equal to 1.5. Okay, and then first we'll find the present value, because it says present value for 1 year, and we use the formula for V equals to 1 over 1 plus I. Then we'll insert the interest, and we'll get for V 1.2 the power of negative 1. And to find the D, the discount, we can find it as well by inserting the interest 0.2 over 1 plus 0.2. Then we get 1 over 6. And for the remaining 0.5 year, we'll find the present value by using the formula AT is equals to KAT, and the AT is using this formula 1 plus IT the power of negative 1. And we'll insert the value of inserting the k by using this v equals 0.2 is here, and then insert this, the t, in the 0.5, then we'll get the value 10 over 11. For the method B, we'll use the same formula, k times at, but the at using this value, or this formula of 1 minus dt of simple discount. Insert the values and you get 11 over 12, and it says computed method A, under method A to that computed under method B. So 10 over 11 over 12 is equals to 120 over 121. So this is the ratio. For chapter 2, number 1, it says in return for payments of $2,000 at the end of 4 years and $5,000 at the end of 10 years, an investor agrees to pay $3,000 immediately and to make an additional payment at the end of 3 years. Find the amount of the additional payment if I to the power of 4 is equals to 0.06. And to do that, first we'll draw the timeline, because it says A3. First for the time 3, for the 3 years, we'll put 3,000 and then plus k because it's additional payment. We do k, and then at time 4 we put 2,000, and at time 10 we put 5,000. And between this and this, the interest rate is for I is equal to 0.06, and by that we know that m equals to 4. Okay, to find the interest, first we use the formula 1 plus I over m, so we insert the value 0.06 over 4, then we get 1.015, and then we let it to be v, and we would do this equation of 3,000 v, the power of 3 times 4. The 4 is the m, and the 3 is this, and it's equals, and then plus k, and equals to 2,000 v to the power of, we put it negative so that we can balance it out, the LHS and the RHS, so that this is m equals to 4, and then 1 is the difference between this 4 and 3, and then plus 5,000 v to the power of negative 7 is from the 10. The difference in 10 and 4 is 6, and then the difference is 4 and 3, 1, so 6 plus 1 is equals to 7, and then the 4 is the m, and then we'll calculate it all, and then we get $1,593. For number 5, whereas the choice of a comparison date has no effect on the answer obtained with compound interest, the same cannot be said of simple interest. So we have to use the formula SI, and then it says find the amount to be paid at the end of 10 years, which is equivalent to 2 payments of $100 each. The first to be paid immediately, and the second to be paid at the end of 5 years. Assume 5% simple interest is earned from the date each payment is made, and use a comparison date of A, we find the end of 10 years. And for A, first draw the timeline. For time 0, we don't know, and then put at 5 years, put 100, and then for the 10 years, the end of 10 years, put 100, and it says the end of 10 years, so we don't know. And for that, and we know that I equals to 0.05, and we'll search, and to find the value we use the formula k is equals to 1 plus IT, 100 get it from here, 1 plus 0.05i, and then 5 from here. Then for this, the same as well, 100, 1 plus 0.05, 10. Then you get the $275. For B, the question says the end of 15 years. And first we draw the timeline where the first year, the 0 year, we don't know. At the 10 year we put 100, and the 15 year we put 100. And then to find that, we at the LHS, the left hand side here, put x times 1 plus it of this, 1 plus 0.05, 5 times 5, t equals 5 equals to 100 times 1 plus 0.05 times 10, and then plus 100 times 1 plus 0.05 times 15. And then you get 1.25x equals to 150 plus 175, and by that you will get $260. The question says the present value of number 8, the present value of 2 payments of $100 each to be made at the end of n years, and 2 n years is $100. If I equals to 0.08, find n. Then we draw the timeline of this. an is 100, a2n is 100, then I, we know that I equals to 0.08, and we'll find n. And to find n, we have to do an is equals to a2n, and then we put 100 is equals to 100 b to the power of n plus 100 b to the power of 2n, and we'll bring it here to the left hand side, and then we'll have this equation, and then we'll have the a equals to 1, b equals to 1, c equals to negative 1. And then we'll insert into this formula, this equation, and then we get 0.6180 and negative 0.6180. We'll reject the negative value, and then we'll use this so that we'll find Vn is equals to 0.6180 to the power of negative 1, and then V will use the formula 1 plus I, so 1 plus 0.08 to the power of n equals to 0.6180 to the power of negative 1, and we'll calculate it, and we'll get n equals to 6.25 years. Number 11, it says A deposits 10 today and another 30 in 5 years into a fund paying simple interest of 11% per year. B will make the same 2 deposits, but the 10 will be deposited by n years from today, and the 30 will be deposited 2 n years from today. B's deposit earned an annual effective rate of 9.15%. At the end of 10 years, the accumulated value of B's deposit equals the accumulated value of A's deposit. Calculate n. And then we'll draw the timeline for A and B. For the 0 year, we put 10, and then for the 5 year, we put 30, and the 10 years, we put 10. And for the B, for AN, we'll put 10, and A2N put 30, and A10 equals K. And for B, the interest is 0.0915, and for A, the interest is 0.11. For A, we'll use the formula simple interest, and for B, we'll use the formula effective rate. Okay, next we'll A10N is equals to A10B, and then we'll let it to be K. Okay, A equals to B at T equals to 10. And then here we use the formula simple interest. We use K times 1 plus IT, so 10 times 1 plus 10 times 0.11 plus 30 times 1 plus 5 times 0.11 is equals to 10 times 1 plus 0.0915 to the power of 10 minus n plus 30 times 1 plus 0.0915 to the power of 10 minus 2n. And we'll calculate all of this, and then we'll get this formula of v power of negative 2n plus 1 over 3 v to the power of negative n minus 0.9374 equals 0. From this equation we get a equals to 1, b equals to 1 over 3, c equals to negative 0.9374. Then we put it into this formula, and then we'll get 0.8158. We ignore this negative value and we put it in this equation, this formula. Then we get n equal to 2.33 years. For question 14, find an expression for the exact effect rate of interest at which payments of $300 at the present, $200 at the end of 1 year, and $100 at the end of 2 years will accumulate to $700 at the end of 2 years. And by this we can draw the timeline of at the present we put 300, and at the end of 1 year we put 200, the end of 2 years we put 100, and then it will accumulate to 700. And then we'll know, and by that we'll know m equals to 1, and we'll use the formula k times 1 plus I of m times t, the power of m times t. Then we put 300, 1 plus I to know the interest, I plus 200 times 1 plus I, power of 1 times 1 plus 100 equals 700. Then we'll let 1 plus I equals to v, and then we'll get this 300v squared plus 200v power of 1 plus 100 is equals to 700. Then we'll calculate, we'll get a equals to 3, b equals to 2, c equals to negative 6. And by that we'll get 1.1196 and negative 1.7863. We'll take the positive value and we'll insert it into this. 1 plus I equals to 1.1196, and the interest will get 0.1196, and we'll have to multiply it with 100% to get the interest rate of 11.96%. Number 18, the sum of the accumulated value of 1 at the end of 3 years at a certain effective rate of interest I, and the present value of 1 to be paid at the end of 3 years at an effective rate of discount numerically equal to I is 2.0096. Find the rate I. For the accumulated value, we use this 1 plus I. We use this formula 1 plus I the power of t, and for present value we use this formula of 1 minus d to the power of t. And by this timeline it says by the end of 3 years the sum of the accumulated value of 1, and this as well, sum of to be paid at the end of 3 years to the present value of 1. And then we use this formula of d is equals to I over 1 plus I, and then we insert it 2.0096 plus 1 plus 2.0096, then we get 0.6677, and then we use this formula and we'll get the present value. And calculating all of this, we'll get I is equals to 0.04, and by multiplying it by 100% we'll get I equals to 4%. For number 20, a sum of $10,000 is invested for the months of July and August at 6% simple interest. Find the amount of interest earned. A. Assuming exact simple interest. B. Ordinary simple interest. C. The banker's rule. Okay, for A, we use this to find the amount of interest earned. For this we have to, this is the formula of actual over actual. This is for the exact simple interest, is the formula. So 31 plus 31 over 365, because July, the days of July and the days of August, we plus, and then we over 365, we multiply it by 10,000 and 0.06, and then we get $101.92. And for B, you need to find the ordinary simple interest. By using the ordinary simple interest, the formula is 30 over 360, but then it says July and August, so we'll have to multiply by 2, 30 times 2, and because the year didn't state the year, so it's 0, so we have to multiply 30 times 2, and then we get 60 over 360 times 10,000 times 0.06, and then we get $100. And for C, it's banker's rule. The banker's rule, the formula is actual over 360. So July and August days, 31 plus 31 over 360, and then we multiply by 10,000 and 0.06, and then we get $103.33.